BSc भाग 2 मधील सर्व विद्यार्थ्यांसाठी आपण आता ऑनलाईन लेक्चर्स चालू करतोय. तर आपण रियल अनालिसिस सेकंड हा चॅप्टर चालू करतोय. ऍक्च्युली रियल अनालिसिस सेकंड फर्स्ट थर्ड स्टेपला फर्स्ट होता रियल अनालिसिस हा चॅप्टर चालू करतोय. ऍक्च्युली रियल अनालिसिस सेकंड फर्स्ट थर्ड स्टेपला फर्स्ट होता आणि आता फोर्थ स्टेपला पेपरचं नाव आहे रियल अनालिसिस सेकंड. त्यातलं पहिलं युनिट आपण चालू करतोय सिक्वेन्स ऑफ रियल नंबर्स. सिक्वेन्स ऑफ रियल नंबर्स, यू नो बेटर द सिक्वेन्स. सो sequence of real numbers. So definition of the sequence of real numbers is a sequence is a function. It is a function. So whose we say that domain is set of natural numbers. Domain is set of natural numbers. What is the meaning of this one? So you know better what is meant by the function. So a sequence is a function whose domain is the set of natural numbers. So for example, consider the sequence 1, 2, 3, 4, 5, 6, 7, etc. dot 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 in this way. Or better 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, etc. dot 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 in this way. So what is the meaning of this? These are the two sequences. So sequence is a function whose domain is the set of natural numbers means what? So we can say that this sequence, first term of this sequence is 1, second term is 1 by 2, third term is 1 by 3, fourth term is 1 by 4, etc. So first, second, third, fourth, these are the natural numbers. So this sequence can be generated by in the form of ordered pairs as in this way. 1 1 means the first term of the sequence is 1. So for this first number stands first term. Second ordered pair is 2 1 by 2. It indicates this 1 by 2 is the second term in this way. So do you get? I think it is clearly because of this is a digital board and this is small one. So every time we have to delete it or we can make here in this way. Okay. So suppose so this is the first one. So we take the second one now. For example, 3, 5, 7, 9, dot dot dot. This is the sequence of odd numbers. So this 3 is the first term, 5 is the second term, 7 is the third term, 9 is the fourth term, etc. Okay. So this is the sequence. This is the sequence. So sequence of real numbers. So in this case, so sequence of real numbers, we have to learn the actually what is the sum or not in this way. We have to learn the limit of a sequence means what. Okay. So limit of a sequence. So suppose in this way. So because of I am using this board first time, there may be trial error methods here. So understand it carefully. So what is meant by the limit of a sequence? Okay. So Sn is the sequence means suppose second term is 1 by 2, third term is 1 by 3, fourth term is 1 by 4, dot 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 in this way. This is the sequence. So we write the sequence, it is in the brackets, in the curly brackets. And we denote this sequence by this bracketed Sn. Sn means nth term of the sequence. And bracketed Sn means a sequence Sn. So name to this sequence is given Sn, bracketed Sn. It means that nth term of the sequence is 1 upon n. We can easily find it, no problem. Now see what is the limit of the sequence actually. Okay, so what is the limit of the sequence we have to learn. So suppose this is the sequence Sn means in this way, means we can write this sequence as this is bracketed 1 upon n, means 1 upon n. Instead of Sn we use sequence 1 upon n. So we have to find the limit of the sequence. What is meant by limit of the sequence we have to learn. See where the term goes here is important one. Now see what is meant by the limit of the sequence. So Sn in this case is 1 upon n, means nth term of the sequence is 1 upon n. Okay. The definition, first we learn the definition of limit of the sequence. So the sequence Sn is said to be converge to some limit L say. If for any epsilon greater than 0 there exists a natural number m such that modulus of Sn minus L is less than epsilon for all n greater than equal to m. What is the meaning of this? We have to learn. What is that is the meaning of this definition. No problem. These words letters are new for you. That is this is not difficult. That is what is this epsilon is taken and what is this modulus of this Sn minus L. Where this L comes from, we have to learn here. So it is important one. So we take the third, that is the we say PPT here. So what is the meaning of this epsilon? Where it comes? This L comes from in this way. Now see the sequence. This is the sequence 1 upon n. Now see the sequence 1 upon n. In this case, what happens now? Sequence 1 upon n, and this is our Sn. This is our Sn. Sequence Sn. Now see, the sequence is actually 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, dot dot dot, 1 upon 1000, in this way. Okay. Now see the number 1, 1 by 2 is 0.5, 1 by 3 is 0.6 something, 1 by 4 is 0.25, 1 by 5 is 0.2. So terms are decreasing. So where it goes is important one. 1 upon 1000. What is the value of that? Is actually 0.001. Am I right? Okay. So this is a very small number. This is a very small number. Now the next terms are 1 upon 1 lakh. So 1 upon 1 lakh is a very small number. So we can say that for this n means terms actually. N greater than suppose 10,000. N greater than 10,000. This Sn means 1 upon n tends to something 0. Am I right? Because 1 upon n means 1 upon 10,000 and is turns towards the 0. Okay, turns towards the 0. So this we say that the sequence 1 upon n has limit 0. We write this in this way. That is the limit of Sn as n tends to infinity is equal to 0. N tends to infinity means terms are bigger and bigger. Tends to infinity. If terms are going to infinity, then the value of 1 upon n tends to 0. It is actually not 0, it is tends to, nearly equal to 0. So this is the, we say that definition. Once again, we see that definition. So, okay. So, the sequence Sn converges to L if for any epsilon greater than 0, there exists m such that modulus of Sn minus L is less than epsilon. So, one thing see one more, that is explanation of this definition. It is in this way. So our sequence Sn is 1 upon n. Sequence Sn is 1 upon n. Now see, Sn is 1 upon n. So see this 1 upon n modulus of 1 upon n minus 0. This difference is less than epsilon. Means for every epsilon means what? For every epsilon means what? Let we take epsilon is a positive number. Suppose we take it is 0.0001, 0001. Means the difference must be that 0.0001. Then where we find that m, so how to find that m? See now. So modulus of 1 upon n minus 0 is less than epsilon, and epsilon means 1 upon 0.0001. Okay. So modulus of 1 upon n means 1 upon n because n is positive, and this is less than 1 upon 0.0001. Means n must be greater than this is I think 10,000. Am I right? N is greater than 10,000. Okay, so this is our m. This is our m. For n greater than m, this difference is very small. That is, it is less than this number 0.001. Okay, so this is actually this is one is mistake. Because epsilon is we taken point 0.0001. It is in this way. So this is not. This is not. This is 1 upon n is less than 0.000 means n is greater than 10,000. Now this is correct one. So understand it carefully. What is the return actually? Okay. So where it comes this one. Okay, this one. So definition once again, the definition of sequence. The sequence Sn converges to L. Sequence Sn converges to L if for any epsilon greater than 0 means positive number, there exists integer actually positive m such that this difference is less than this epsilon for all n greater than equal to m. This is the definition of limit of a sequence. So limit of a sequence. So one thing is we have seen just that is the what is how this sequence 1 upon n tends to 0 as n greater than m means whatever is that number. Okay. So that is another example. So we take it. That is see that we take a blank sheet now. So another example means sequence Sn, and this is suppose this is 1 1 1 1 dot in this way. We say that this is a constant sequence. This is a constant sequence. So this sequence, nth term of the sequence is 1. So where the terms are getting towards the larger and larger, this Sn is 1. So we say that this Sn tends to 1 as n tends to infinity, means number of terms tends to infinity, Sn becomes 1 only. Okay, Sn becomes 1. So we say that limit of the sequence Sn is 1. We write in this way. Limit n tends to infinity, Sn is equal to 1. So this is the constant sequence, and constant sequence converges to that number. So whatever we 1 or k, no problem. Another I think we take it, that is sequence minus 1 raised to n. So check that what are the terms actually. Minus 1 raised to n means n is equal to 1, then it becomes minus 1. N is 2, then it becomes plus 1. So terms are alternately positive, negative, and that are 1. That is minus 1 plus 1 in this way, dot 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 in this way. So this is my first lecture on this digital board. So something may be going wrong to operate this board. So understand it carefully. So minus 1 raised to n, the sequence is in this way. Now we learn what is the limit of the sequence. As the term increases, the that term is plus 1 or minus 1. So we can't say the sequence Sn converges to 1 or minus 1. This is very difficult. So we say that this sequence is oscillatory sequence. This is oscillatory sequence. Okay? Oscillatory means it has no finite limit. That is confirmed finite limit. That is this limit of the sequence may be 1 or minus 1. So this does not converge or diverge. Okay? So this is oscillatory example of oscillatory sequence. Now see what is meant by divergence of a sequence. So suppose sequence n. Simple example, sequence n. 1, 2, 3, 4, 5, dot, dot, dot in this way. See the sequence n. What is the limit of the sequence n? So as that is terms are going to be larger and larger, that term of the sequence is also very large. So in this case we say that is limit of the sequence is infinity. That is we going larger and larger terms. This Sn means actually n, that is limit of this sequence n as n tends to infinity is infinity. In this case we say that the sequence n is a divergent sequence. This is oscillatory sequence. Sequence 1 upon n is convergent sequence. So these are the simple but important concepts. Okay. So now see, if sequence Sn is a sequence of non-negative numbers and if limit of Sn is L, then L is positive. No problem. That is simple. That is sequence Sn is the we say that this is the terms in the sequence are positive. Terms in the sequence are positive, and limit of Sn as n tends to infinity is equal to L. Every term in the sequence is positive, and limit of Sn is L. It is given, and then we say that this L is greater than equal to 0. No problem. Sn is this is the sequence of positive terms, and limit of Sn is L. Then L must be positive. This is simple case. No problem. So what is meant by convergent sequence? We have seen the 2-3 examples. We are not going to do any theorem because your exam is again, I think, institute type. So we are not going to spend time on this to that is prove the theorems. Now, one more concept we have to learn is subsequence. That is what is meant by the subsequence. Okay, so consider the sequence 1 upon n. Sequence 1 upon n. So 1 upon n, we know that the terms are in this way: 1 by 2, 1 by 3, 1 by 4, dot 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 in this way. So suppose this is the sequence Sn. Okay, we give name to the sequence Sn. Now see the sequence. Suppose any another sequence Pn, for example. And the Pn is in this way, that is 1 by 3, 1 by 5, 1 by 7, dot 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 in this way. Then we can say that the sequence Pn is subsequence of the sequence Sn. Clearly, because all the terms in the sequence Pn are in Sn and they are in order. That is 1, then 1 by 3. This is not allowed. That is 1 by 3, 1 by 7, 1 by 5, dot dot dot. This is not a subsequence. This is not a subsequence of the sequence Sn. So terms must be in order. Sn मध्ये जशा टर्म्स आहेत त्या ऑर्डरच्या त्याच्यामधल्या टर्म्स पाहिजे, पण त्याला म्हणतो आपण सबसिक्वेन्स. सो आय थिंक दिस इज example of subsequence. So easily you get it. So this is no problem. So let me take the next slide. That is what is subsequence. There is one theorem on subsequence. That is if Sn is a sequence and it is convergent, then limit of Sn is L set as n tends to infinity. Suppose Pn is a subsequence. Pn is subsequence of sequence Sn. There is something problem to write on this board because I have not practiced on this board. Yet we have in all our service I used the that is chalk and the board. So it's somewhat difficult to write on the by using this pen on this digital board. So understand, after this video, if you have any problem, ask by using yourself, no problem. So Sn is a sequence and it is convergent and limit of Sn is L, and Pn is the subsequence of the sequence Sn. Then the theorem is that this limit of Pn as n tends to infinity is also L. That is, if sequence Sn is convergent and converges to this limit L, then its subsequence also converges to the limit L. This is one theorem. We are not going to prove this one. We see one by one, no problem. So, convert, that is subsequence converges to L. That is important one. So, this is in case of convergent sequences. Am I right? That is, if Sn, once again I want to write it, or we see the previous slide. That is, if Sn is a convergent sequence, this is short form, I used here CGT for convergent. If Sn is convergent sequence, then its subsequence is also convergent and converges to the same limit L. So we have seen this one. Now see this one. That is sequence Sn. Sequence Sn. So sequence Sn, suppose this is minus 1 raised to n. We know that this is oscillatory sequence. This is oscillatory sequence. Okay. Now see the subsequence of this sequence Sn. Suppose Pn is subsequence. So suppose 1, 1, 1 were taken in this way. Okay. This is clearly the subsequence of sequence Sn. But this sequence Pn is convergent. But sequence Pn is convergent and converges to 1, clearly we know that. So if it is oscillatory, then it is subsequence may be convergent or divergent, no problem. So what is the theorem? Once again we have to learn that, because of that is important one. If Sn is convergent sequence and converges to L, then its subsequence Pn is also convergent and converges to the same limit L. Okay. So we take the next slide in this one. So next we have to learn bounded sequence. Because of this is first one, we stop here. 9 slides are completed, and this is my first try to create this that is lecture. So sorry for that. Next video may be 50 or 45 minutes video. So this is I think 25 to 30 minutes video. Maybe this तुम्हाला हा व्हिडिओ आवडेल आणि तुम्ही हे पहा व्यवस्थित. काही शंका असतील तर फोनवरून मला पाठवा. ओके, थँक्यू.